Gopher tortoises, a keystone species and ecosystem engineer which constructs extensive burrows, are imperiled. It is imperative that we efficiently and accurately detect their burrows, but we haven't changed how we detect them for 20 years. It is time for a change, and technology may have the answers that we need. Hello, everyone. My name is Julianne Gibson, and I'm a fourth-year wildlife ecology and conservation major with a specialization in quantitative ecology. I am conducting research on the effectiveness of unmanned aerial vehicles for the detection of Gopher tortoise burrows during prescribed fire cycles. I am conducting this research through the UF Deer Lab with support from Dr. Marcus Lashley, PhD student Adrian Detraska, and funding through the University Scholars Program. Gopher tortoise burrows are ecologically valuable as they provide shelter and habitat to other species and have been found to have a positive effect on vertebrate biodiversity. In modern studies and management, Gopher tortoise burrows are detected by walking line transects, which requires a significant amount of manpower. Often, this is done after prescribed fire. Fire, which is native to the longleaf pine habitats which gopher tortoises live in, is important for gopher tortoises as it maintains open canopy conditions and promotes growth of herbaceous ground cover which gopher tortoises feed on. Further, thick understory conditions increase difficulties locating burrows as they are well hidden under vegetation in these conditions. With prescribed fires being key to improving and maintaining the tortoise's habitat, detection of their burrows after a fire for population dynamic studies remains to be an issue for researchers, but a necessary key in continuing to conserve this species. In my research, I am flying line transects using UAVs or drones, as well as walking them throughout a prescribed fire cycle in order to analyze the effectiveness of the use of UAVs in comparison with traditional line transects distance sampling, with consideration for the effects of vegetation and prescribed fire. After walking transects for a certain amount of time and flying the same transects for the same amount of time over a 6-week period, visual counts of burrows will be statistically compared to determine if the use of UAVs will significantly improve detection of burrows while simultaneously reducing the amount of time and effort required for gopher tortoise burrow research. Thank you so much for your time.